Welcome to this Any Excuse for a Chemistry Experiment video. If you're studying for your GCSE Chemistry exam, there is a good chance that this required practical will come up or the science behind it. We're going to be looking at the electrolysis of aqueous solutions. We'll go through the experiment, the scientific principles and exam style techniques. Feel free to jump to the bit that you need or watch it through. To be confident with this required practical, we must be confident with the equipment, the products formed and the tests for hydrogen, oxygen and chlorine gases. If we keep this in mind, we'll be okay. The usual experiment is to test 4 known aqueous solutions: sodium sulfate, sodium chloride, copper sulfate and copper chloride. We need to fully understand that aqueous solutions include our dissolved substance and water. Water will partially split into hydrogen ions and hydroxide ions. These ions can also be manipulated when the electricity is switched on. Setting up the experiment and what to look for. We need to be confident with the names of the equipment and the procedure. The equipment we will need: a power supply, leads, a 250ml beaker or a Nelson cell. Here's an example of a Nelson cell and it is just like your electrolysis cell but the cup has been done for you and the electrodes are sticking through the bottom. 2 graphite electrodes, crocodile clips and the 4 aqueous solutions. Set up the experiment. Connect the crocodile clips to the leads, attach the leads to the direct current supply, attach the graphite electrodes to the crocodile clips, fill your beaker or the Nelson cell with one of the solutions. Insert the electrodes, ensure they don't touch. Turn on the power supply. 6 volts should be sufficient. Leave for 30 seconds and observe the effect on each electrode. Turn off the power supply and repeat with the 3 other solutions. Let's have a closer look at the science. When we have aqueous solutions, we need to consider that there are 2 positive ions: the metal ions from the ionic compound and the hydrogen ions from the water. There are also 2 negative ions: the salt ions from the ionic compound and the hydroxide ions from the water. The ion that is attracted to the electrode is dependent on how reactive it is. We will need to remember these 2 rules. Rule 1. For the positive ions, if the metal is more reactive than the hydrogen, hydrogen gas will form at the negative electrode. If the metal is less reactive than hydrogen, the metal will form at the negative electrode. Rule 2. For the negative ions, if you have the halide ions chloride, Cl-, bromide, Br-, or iodide, I-, their molecules will form. If those halides are not present, oxygen gas will form at the positive electrode. Let's use these rules to predict the product of electrolysis of our 4 solutions. Sodium sulfate. We would see bubbles at the negative electrode. Sodium is more reactive than hydrogen. The bubbles are hydrogen gas. We would see bubbles at the positive electrode. There are no chlorides, bromides or iodides in the compound. The bubbles are oxygen gas. Sodium chloride. We would see bubbles at the negative electrode. Sodium is more reactive than hydrogen. The bubbles are hydrogen gas. We would see bubbles at the positive electrode. Chlorides are present in sodium chloride. The bubbles are chlorine gas. We would smell the smell of swimming pools.
Copper sulfate. We would see the electrode change colour from grey to pink-orange. Copper is less reactive than hydrogen. Copper metal is forming. We would see bubbles at the positive electrode. There are no chlorides, bromides or iodides in the compound. The bubbles are oxygen gas. For the copper chloride, we would see the electrode change colour from grey to pink-orange. Copper is less reactive than hydrogen. Copper metal is forming. We would see bubbles at the positive electrode. Chlorides are present in copper chloride. The bubbles are chlorine gas. We would smell the smell of swimming pools.
We have covered what is formed in electrolysis. Now we can quickly look at how they form. Do you remember redox, reduction and oxidation? Reduction happens at the negative electrode. Oxidation happens at the positive electrode at the same time. At the negative electrode, the positive ions are reduced. The ions gain electrons to become atoms. In the case of hydrogen, 2 atoms of hydrogen will join together to form hydrogen gas, H2. At the positive electrode, the negative ions are oxidized. The ions lose electrons to become atoms. In the case of chlorine, 2 chlorine atoms join together to form chlorine gas, Cl2. When oxygen forms, we need to look at our source of oxygen in our equations. The oxygen comes from the hydroxide ion from the water. We get 4 hydroxide ions that form an oxygen molecule, O2, 2 water molecules, H2O, and they lose 4 electrons into the circuit. The last skill we need is to be confident with the tests of hydrogen, oxygen and chlorine gases. Hydrogen gas is the easiest to remember, but the easiest to get wrong. The test is a flame test. The result is the squeaky pop. No lab in the world has a cupboard with a squeaky pop in it. Oxygen gas can be tested in 2 ways. The most common way is using a glowing splint. The result is it relights. Or we could use a lit splint and the flame will glow brighter. For chlorine gas, the test is damp blue litmus paper. The result is that it bleaches the litmus paper. Let's have a look at some exam style questions and tips. I've seen 3 types of questions around this experiment. The predict the products question. Suggest how a student could carry out the electrolysis of aqueous copper chloride, state the products at each electrode and explain how they formed. What about the is my hypothesis correct question? A student notices that copper forms when they electrolyse copper sulfate. They state that metal will always form at the negative electrode. Do you agree? Explain your answer. And then the more challenging one, the half equations question. Describe what happens at each electrode when sodium chloride solution is electrolysed. Complete the half equation at each electrode. Very few questions that I've seen ask you for a method. But if they do, have your method prepared. Set up a 6-volt battery supply with leads and crocodile clips. Connect 2 inert graphite electrodes to the crocodile clips. Pour your aqueous solution into a beaker or Nelson cell. Insert the electrode into the solution. Turn on the power and observe. Most types of questions rely on your knowledge of the 2 rules that we came up with. Fix them to memory. For the positive ions, if the metal is more reactive than hydrogen, hydrogen gas will form at the negative electrode. If the metal ion is less reactive than hydrogen, the metal will form at the negative electrode. For the negative ions, if you have the halide ions chloride, Cl-, bromide, Br- or iodide, I-, their molecules will form. If the halides are not present, oxygen gas will form. The remaining and higher level questions want you to write out half equations. Remember, the half part describes something different happening at each electrode. The equation bit describes reactants going into products. Balance the equations by looking at the formula of your product. Balance the number of ions that you start with, then add the electrons. If the ion gains electrons, the electrons will be a reactant. If the ion loses electrons, the electrons will be a product. This required practical needs you to know lots of technical information, learn the rules and how to write those half equations. Thank you for viewing this video. I'll post all the required practicals into this playlist. If you found it useful, please subscribe. Click the thumbs up button. Look out for more videos to help you with your GCSE Chemistry. Thank you and goodbye.